We are getting ready to talk about section 7.1, which is entitled Antiderivatives. And in order to understand antiderivatives, you first of all have to really be good with derivatives. So what I want you to do right now is to pause the video, and below are 8 problems that review just the basic derivative rules, just the basic ones. So pause the video and go through those 8 basic derivative rules, and then we'll talk. And now let's start talking about antiderivatives. You'll recall the fundamental theorem of calculus, which looks like this. Looks very complicated, but hopefully by now, after studying calculus for over half a year, you know that this is a rate. And so what this really says, if you integrate the rate of some function between 2 points, and I think of these as time periods, then that's just the change in that original function for those 2 time periods. Okay, so that's what you've been doing so far. And the question becomes, how do I find this function f given the derivative? Could I do that? In other words, undo the derivative or take the antiderivative. Okay, so how is this different from what we've been doing? Well, what we've been doing so far is called a definite integral. For example, if I say I want the integral from 3 to 4 x squared dx. There's lots of ways you can think of this. One way would be look at it as a graph. And from 3 to 4, the integral represents this area under that graph. So you're expecting to get a number out. So that's one of the big differences between what we've been doing and what we're going to do next. You will get a number out. That's called a definite integral. Okay, the indefinite integral, or the antiderivative, would look something like this for that problem. So the first thing you notice is that, there are no limits of integration. Got some numbers missing. So it's pretty hard to think of this graphically as an area under curve because you don't know where to start and where to end. So this is called the definite integral. You have limits of integration. You're going to get a number for an answer. The indefinite integral, for starters, will not have any limits of integration, and you're not going to get a number for an answer. You're going to get a function for an answer. And how do you know what function you're going to get? This function, when you take the derivative, you should get x squared. So I could probably say, okay, try to guess what function that will be, and hopefully some of you would guess. Well, if I'm going to take the derivative and end up with x squared, I better start out with x cubed. But if I take the derivative of x cubed, I get 3x squared. So my function should be 1/3 x cubed. Because if I take the derivative of 1/3 x cubed, I get x squared. Good thinking. But you're not all the way done. What about if I said, oh no, I think the function could be 1/3 x cubed plus 5. Well, to check it, I take a derivative of this function. Is it x squared? Sure it is. And somebody else will say, no, I don't think it should be a plus 5. I think it should be a plus 7. They're right also. Okay, so you're not only going to get a function, but you're going to get a whole family of functions. Comparing these two ideas, the indefinite integral is called the antiderivative. You can use either terminology. The notation looks a lot like the definite integral, so notice this right here looks a lot like the definite integral, except these are missing. And my answer is going to be a function whose derivative is this function. And as I just pointed out, there's not going to just be one answer. There's going to be a whole bunch of functions that have a derivative of this. So that's what we're going to talk about learning how to do today. Okay, so how do we find the function whose derivative is what you're trying to integrate? Well, it's related to the derivative rule. So let's go back over the derivative rules and see if we can develop constant. So if I say find the derivative of 7, your answer to me, I hope, is 0. Derivative means how much does it change? If it's a constant function, there is no change, so you get 0. So that means if I'm going to integrate 0, I'm looking for some function that has a derivative of 0. That's going to be any constant. And now you get tired of writing out any constant in calculus for every single problem. So in calculus, we abbreviate that with a capital C. That stands for any constant. Okay, on number 2, if I asked you to take the derivative of x to the 5th, we did that, we reviewed it, it's 5x to the 4th. So if I want to integrate, here, what we did here was multiply and lower. If I want to integrate, we just did this a minute ago, x squared dx, what we said was raise this by 1, so I'm going to have x to the n plus 1. So this would be x cubed. But if I take the derivative of x cubed, I don't get x squared, I get 3x squared. So I have to divide by that n plus 1. And I prefer to think of that as 1 over n plus 1 times x to the n plus 1. So I would think of this as 1/3 x cubed. You can instead write it as x cubed over 3. However, like we just talked about, 1/3 x cubed plus 7 is right. 1/3 x cubed plus 12 gives you the right derivative. So this is going to have to be plus c. I'm still learning to write on this little screen. And once again, the derivative of ln x is 1 over x. So that means the integral of 1 over x is going to be the natural log of x. And since x always has to be a positive number if you're taking the natural log, some books will insist you write an absolute value. I don't really care, but you will see that written that way sometime. And then once again, plus a constant. So here's your first 3 antiderivative rules. They're associated with the derivative rules. We have 2 more. Oops, 3 more. Since the derivative of sine is cosine, then that means the integral of cosine is going to be sine, because the derivative of sine is cosine, so that means I'm right, but plus a constant, because if I had sine x plus 7, when I take the derivative, I get cosine x. So once again, you are always checking to see if I take the derivative of this, it better be that function. This next one gets a little tricky because the derivative of cosine is not sine. Hopefully you remember that. It is negative sine. So if I claim that the integral of sine is cosine, I'm not correct, because when I take the derivative of cosine, I get negative sine. So I'm going to have a negative 1. So now when I take the derivative of this, the derivative of cosine is negative sine, but there's already the other negative sign out there, so it does give me sine x. So there is your integral of sine. And this is the easy one. It's sometimes hard because it's so easy. Since the derivative of e to the x is e to the x, the integral of e to the x is e to the x plus a constant. Now once again, why am I doing plus a constant? Because I check my answer by taking the derivative of this, and if it's that, then I've got a correct answer. But when I ask you for the indefinite integral or the antiderivative, I want all the answers that will give me a derivative of e to the x. So e to the x plus 7 works, e to the x plus 12 works. So when you're taking an indefinite integral, you're going to always have plus c at the end of it. Okay, so here's some examples. The indefinite integral of sine x. Well, first of all, you think it might be cosine x, but the derivative of cosine is negative sine, so you're going to have a negative out in front of that. And then once again, to get a 3, the constant, you're just going to have a 3 there. So it's sort of like derivatives in that a constant multiple really just gets thrown into the answer, plus a constant. Now, to check myself, I'm going to take the derivative of this. So when I take the derivative of this, I get negative 3 times the derivative of cosine x is negative sine x. The derivative of the constant is 0, and this does give me my integrand. So that means that, yes, I've got the right answer because, in fact, I've got all the right answers. It's a whole family of functions. Negative 3 cosine x plus c. For the next one, once again, this plus sign right here says that I can just separate these as two separate problems. And this one we've done as an example a couple times. It's 1/3 x cubed and then the 3x. I'm going to just write the 3 down. The constant multiple just gets included in. When I raise this by 1 and divide by that new number, so for this part I get 1/2 x squared, and I multiply it by 3, and that might be written as 3/2 x squared, plus a constant. Let's check ourselves. The derivative of this is going to be 3/3 x squared, so that checks. The derivative of this is going to be 2 times this, cancels the 2 at the bottom, so I get 3x, and so that whole thing works. The next one, I'm going to think of this as x to the minus 1 minus x to the minus 2. Now, when I try to integrate this with the power rule, I run into a problem. Because when I raise that by 1, that's not a problem. X to the 0 is 1, but dividing by that new number, oops, I can't divide by 0. So hopefully you remember that this is a special rule, and the special rule is the integral 1 over x is ln x. Minus, now we can integrate this the usual way, raise this by 1, but remember when you raise that by 1, it becomes negative 1, divide by that new number. So I'm going to first of all write this like this. Now, you will never see it written that way on a multiple choice. And when I read an answer, I would never read it like that. So you might as well learn to simplify it. The first part stays ln x. This negative sign and this negative sign really multiply together and cancel each other out. And x to the negative 1 can be written like this. So that's the way that answer, the third answer there, will probably be written. And the integral of sine x, once again, you have a plus sign there, so you're just going to integrate each separate little part. The integral of sine x is negative cosine x. Once again, take the derivative of this, and it will be sine x. And the derivative of e to the x is e to the x, plus a constant. Okay, so there's some examples. You got to wrap your head around going backwards, finding the antiderivative. It's just like in 3rd grade when you learn to multiply 3 times 6 to get 18. Oh my gosh, the next thing they asked you to do was go backwards. Take 18 divided by 3. And if you didn't know those multiplication tables, you were in trouble. So this is what we're really doing now on a ramped up level. You're seniors after all. Okay, so pause this and try these problems. Okay, hopefully you tried those problems. We'll check them when you come to class. So you need to make sure those get done. I'll be checking, so be sure they get done. If you have questions, I'll be glad to go over them. The next step is one more little detail. Up until now, our answers have been a whole family of functions. What does that mean? Well, you got answers like 3x squared plus 2x plus a constant. So everything in that function starts out with this and then could have a different constant. So it's a whole bunch of functions, but they have something that looks alike. It's just like your family. You have a lot of things that look alike. Excuse me, but there's something different there too. Okay, so now you can find out exactly what this constant is, exactly which function you're talking about, if you're given some more information. So here we have, says find the antiderivative f of x if it's the integral of this, and then there's also this little other piece of information. Okay, so let's start talking about how to do that. The first thing you're going to do is, let's see if I can get this up here out of the way. The first thing you're going to do is find the antiderivative. So you're going to write that as x to the 1/2 plus 5 dx. And when you raise this by 1, you get x to the 3/2. Divide by that new number. But now when you divide by 3/2, that really flips over and multiplies, so you get 2/3 x to the 3/2. And then this, I prefer to think of this as 5x to the 0. At any rate, if you are trying to think of some function that has a derivative of 5, you're either going to raise this by 1 and divide by that new number, or just reason it out that it's got to be 5x plus a constant. So here is the first part of our answer. There's the general antiderivative. Okay, then to find the specific function, this says that if I plug 4 into this function, I get a 3 out. So 2/3 times 4 to the 3/2 plus 5 times 4 plus your constant has to equal 3. That's what this says. Plug a 4 into my function and I have to get a 3 out. Okay, so now either using your calculator or working through it, you're going to get, I don't have my calculator around, so I'm going to 2/3 times, this is going to be 4 times 2, 8, plus 20, plus c equals 3. C is going to equal, this is going to be 16/3 or 25 1/3, so c is going to equal 3 minus 25 1/3. So I get negative 22 1/3. So my final answer is f of x equals 2/3 x to the 3/2 plus 5x minus 22 1/3. That's my final answer. Okay. Okay, here's another example. Here we have find the antiderivative if that antiderivative is the integral of this and f of 1 equals 5. Okay, so first of all, let's do this first part. Let's see if I can scrunch it up a little bit better. The first part will be the integral of 1 over x is ln x, and once again, you might use an absolute value. If you don't, won't be wrong. The integral of 2 is a 2x. So that's my function. That's the antiderivative. And then the next part says that I have to have f of 1 equals 5. So that says the natural log of 1 plus 2 times 1 plus c has to equal 5. So solving the natural log of 1 is 0. So c is going to equal 5 minus 2, 3. So my final answer is f of x equals ln of absolute value of x plus 2x plus 3. And if I check myself by taking the derivative of this function, so here I'm checking, the derivative of this would be 1 over x plus 2, so that fits this part of it. And then if I say f of 1 is supposed to be 5, if I put a 1 in there, I do get a 5 out. So that means that answer checks. Okay, so now you get to practice 5 problems. All of them are multiple choice. Just choose the correct answer. And you might show your work in the space below the problem. So the first one says find an antiderivative if the derivative is this and g of 0 equals 4. So you're going to integrate z minus radical z. I make my z's like that because they don't look like 2's then. dz. You're going to first of all do that. And you will have plus a constant here. And then this little piece of information will allow you to solve for the constant. Okay, so let me go ahead and finish that first problem. So when I integrate z minus z to the 1/2, that's what radical z is after all, I get, raising the power by 1, dividing by the new number, 1/2 z squared, you might write that as z squared over 2, minus, if I raise this by 1, I get z to the 3/2. Then when I divide by 3/2, when you divide by a fraction, it flips it over and multiplies by the reciprocal, so it's 2/3 plus a constant. So there's the first part of my answer. Then the second part says, right here, if g of 0 equals 4, that means when I put a 0 in there, 1/2 times 0 squared minus 2/3 times 0 to the 3/2 plus c, I have to get a 4 out, so that tells me c equals 4. So my answer is all of this with my c as a 4. So I'm going to get 1/2 z squared minus 2/3 z to the 3/2, so it's letter C. Now, probably some of you have realized that since you have a multiple choice, one way you could do this is just take the derivative of your answers, and it's got to be equal to that z minus radical z, and put 0 in, but I guarantee you won't always have multiple choices. So this is really working the problem out as if you didn't have a multiple choice and then just picking the best one. So there's your homework assignment. What have we learned new? Indefinite integrals versus definite integrals. And once again, these are both integrals. I left off that integrals. You can tell by the way they look, this one would be like from 3 to 5 of 2x squared plus 3. And you're going to get a number answer. This one would look like integral of 2x squared plus 3, no limits of integration. So you're going to get functions out. And I say functions because it's going to have a constant there at the end, a whole family of functions. And then if you're given further information, you can identify that constant. So come to class next time with all the questions answered that I left for you to do, and we'll practice more on indefinite integrals or antiderivatives.